Hello students, today we will see the electric current. Okay, so now we know what is a charge. Okay, and then we are moving to study electric current. Okay, so electric current, it is the physical quantity, okay, that is related to charges. Its symbol is I. Okay, it can be small I or capital I, you can use anyone, and this is called as the rate of flow of charge. Okay, rate of flow of charge per unit time is called as electric current. Okay, now from this definition, its formula can be I is equals to Q by T. Q is the charge. Okay, it is the amount of charge which is flowing, and T is the time taken by that charge to flow. Okay, so this I is equals to Q by T. And we know the units of charge and time. Okay, the unit of charge is coulomb and time is seconds. Okay, so the unit of electric current is, it will be coulombs per second. Okay, or we can say coulomb second inverse. But see, this unit is not SI unit. Okay, this is renamed as ampere. Okay, it is named as ampere. So we can say that 1 ampere is equals to 1 coulomb per seconds. Okay, ampere is the SI unit. Okay, and this is the fundamental unit. Okay, see, in physics we have few fundamental units from which the other units, the units of the other physical quantities are derived. Okay, so this ampere is one of those fundamental units which are used. Okay, charge is not a fundamental unit, but ampere is a fundamental unit. Okay, then this is about the electric current. Okay, and when we classify the electric current, so based on the direction, it whether it will have direction or not. Okay, so it is called as a scalar. Okay, it is a scalar quantity. It is a scalar quantity, but it will have direction. Okay, how that direction is not considered? Because direction can be only two. Okay, we have a wire. Okay, so it has two ends. Okay, let's take, this is a wire. Okay, so the current can flow from two directions, either from A to B or from B to A. Okay, so it will have only two directions, it will have no other direction other than these two. Okay, that's why it is called as a scalar quantity. Okay, so this is the electric current. Okay, now from electric current there is a quantity called as current density. Current density. Okay, current density is what, like whenever we get this term density, it means that we are dividing it with some volume or area. Okay, like that. Okay, so here also current density, it is the ratio of current to the area, or we can say that the amount of current passing through a unit area. Okay, amount of electric current passing through unit area. Okay, so the formula will be current divided by area. Okay, and the symbol of current density, it is J, it is capital J. Okay, this is the formula. So it will become J is equals to I by A. Here A is area. Okay, this is the formula of current density. And now we can find the unit of current density. Okay, so what will be the unit of current density? We have to use the units of current and area. Okay, so the unit of current is ampere, area is meter square, so its unit will be ampere per meter square. Okay, this is the unit. The abbreviated form, it can be represented as this. Okay, this is the current density. Okay, now see the concept of drift velocity. Okay, so when we take any conductor, okay, when we are taking, suppose there is a wire and we are observing this. Okay, the current, let's say the current is moving from left to right. Okay, left to right, it is the direction of current. So what we will observe, we will observe that this is the flow of current, direction of current. Okay, but the direction of flow of charges, the negative charges that are electrons, that will be reverse. Okay, charges will move from right to left. Okay, and inside the conductor, this is a metallic conductor, so there are a number of electrons inside it. Okay, which will move in the left side direction. Okay, so what happen when they will move? Okay, when these two ends are connected with the terminals of a battery. Okay, this is connected with the positive terminal and this is connected with the negative terminal. Okay, so then this current will flow. So what happens at this right end? Okay, right end, these electrons will experience some repulsion from that negative charge. Okay, negative charge that is drawn from the battery. So they will try to move, try to drift in the left side direction. Okay, and they will not move in a straight line, they will move in something random direction like this. Okay, this, and it will go to some distance, and after that it will strike with the another electron, then it will change its direction. Okay, then it will go to some distance, again it will strike. Okay, so it will continuously move its direction and there will be a random motion. Okay, and finally it will reach the left end. Okay, the other end of the conductor. The same happens with the all the electrons. Okay, so these electrons finally reach the left end. Okay, and that's why there is a flow of charge, and so there is a electric current. Okay, so this motion of electrons, we call it as drift. Okay, this is called as the drifting of electrons, and this we take that the electrons have some drift velocity. Okay, drift velocity, we take it is as Vd. Okay, this is the average time by which these electrons, the average velocity with which these electrons reach to the other end. Okay, now what we have to do, we have to use this. Okay, and let's take the number of electrons per unit volume. Okay, we call it as electron density. Electron density, it is n. Okay, it is the number of electrons per unit volume, and let's say the current, the area of this cross section, it is A. Okay, cross section area, it is A. Okay, and suppose the time taken by the electrons to reach the other end from right to left is T. Okay, time taken, it is T. Okay, then what we can assume here, we have to finally calculate the charge, how much charge is flown from right to left. Okay, so the charge flowed, okay, let's say it is Q. Okay, so the charge is the we have to calculate the total number of electrons. Okay, how many electrons will move from right to left? We know electron density n. Okay, this should be multiplied with volume. Okay, but here we have cross sectional area and no length, but we have drift velocity. Okay, velocity is the length per unit time. Okay, so when we multiply this, when we multiply area and drift velocity, we get the volume per unit time. Okay, volume per unit time. So when we multiply this with time, we get the volume. Okay, so this A into Vd into T, this will be volume. Okay, so this n is multiplied with the volume. Okay, so we get the total number of electrons which have passed from right hand to the left hand, and these electrons will have charge E. Okay, each electron has charge E, so by multiplying it with E, it is the total charge. So here we can write Q is equals to NEA VD T. Okay, then this T, the time which we have taken, if we bring it to the left side, it will be charge divided by time is equals to NEA VD. Okay, and we have seen what is charge divided by time. It is the current. Okay, so it will become I is equals to NEA VD. Okay, we call it as the current. Okay, here this current is represented in the form of the electron density, the electron charge, the cross sectional area, and drift velocity. Okay, so this is the another formula, another way which we can write the current, electric current. Okay, thank you.